All right, babies. So in this little movie, we're going to go ahead and learn how to identify if a systems of equations has no solution, one solution, or infinite amount of solution. So if the lines are parallel, we already should know this, there is no solution because those two lines will never ever meet, okay? So if the lines are parallel and there's no solution, the system is considered inconsistent, okay? And you don't need to worry about this. I will give you a little cheat sheet with this in it. Um, if it has one solution, which means they intersect, those would be perpendicular lines or any other lines that do not have the same slope. Um, the system is considered consistent and independent. Okay? But if it's the same line, which is exactly the same line, then the system is consistent but dependent. Okay? So I'm going to keep this handy so that we can go ahead and identify if the lines have no solution, one solution, or infinite amount of solutions, and if they're inconsistent or consistent, and if they are consistent, they need to be divided or classified into independent and dependent. Okay? So have this out so that we can do this together. All right. So if they're not solved for y, that's the first thing that we need to do because this is all about looking at slopes. I really do not need to figure out if they, I don't need to see how they graph. I just need to take a look at slopes, okay? So the first one, this one, we don't have to do anything with it. But then on the second one, I have to solve for y. Okay, so I have an invisible one over there. So I'm going to go ahead and say minus x on both sides of the equation. And I get that negative 1y equals negative x plus 2. I also have an invisible one right beside the x. So this equation ends up being y equals negative 1 divided by negative 1 is x. And then 2 divided by negative 1 is negative 2. Now, these two lines obviously do not have the same slope. They're actually perpendicular, which means they're going to have one solution. And if they have one solution, then they're considered, I'm sorry, if they have one solution, then they're considered consistent and independent. So these are consistent and independent. And I'm going to go ahead and write um, IND for independent. All right, so that was number one. Let's go to number two. The second one is already solved for y, so it's x plus 3. But the first one, we're going to have to solve for y. So in order to solve for y, I'm going to add x. So that ends up being y equals x minus 2. Now these two lines have the same slope, so obviously they're going to be parallel lines. So if they're parallel lines, they have no solution and they're considered inconsistent. Okay? So for number 2, it is no solution and inconsistent. We're going to start abbreviating in a minute because you know Miss Marine doesn't like to write that much. All right, so let's go to number 3. All right, for number 3, 6x minus 7y equals 5. And then my second one would be 12x minus 14y equals 10. Okay, so minus 6x minus 6x, negative 7y equals negative 6x plus 5. And now I'm going to divide by negative 7. So y equals 6, 7x minus 5, 7. So that's the first one. And for the second one, it would be minus 12x So negative 14y equals negative 12x plus 10. And now I'm going to divide by negative 14. So I'm going to go ahead and simplify. Negative divided by a negative is a positive, and I can simplify by 2, and that would be 6, 7x. And then this one would simplify to negative 5 sevenths. Now those two are exactly the same line. So because they have the same line, they're going to have an infinite amount of solutions. And they're going to be consistent and dependent. They depend on each other because it's the same line. So consistent and dependent. So CON for consistent, DEP for dependent. All right, so that was number 3. Let's go ahead and do number 4. So for number 4 is 2x plus 3y equals 4. X minus 5y equals negative 11. So for the first one, minus 2x. So 3y equals negative 2x plus 4. And now I'm going to divide by 3. And y equals negative 2/3 x plus 4/3. Minus x. Negative 5y equals negative x minus 11. Divided by negative 5. I have an invisible 1 right over here. So y equals 1/5 x plus 11/5. These are definitely not the same slope and not the same line. To be the same line, you have to have the same slope and the same y-intercept. This is obviously not true, so this has one solution. And if it's one solution, is consistent and independent. They don't depend on each other. So CON for consistent, IND for independent. All right, let's go to number 5. So for number 5, 4x plus 2y equals 4. And the second one is 6x plus 3y equals 6. Minus 4x. So 2y equals negative 4x plus 4. And now I have to divide by 2. So y equals negative 2x plus 2. Minus 6x. 3y equals negative 6x plus 6. Divide by 3. Y equals negative 2x plus 2. Now these are obviously the same line. Same slope, same y-intercept, so they're the same line. Which means they have an infinite amount of solution. And when you have this tomorrow in front of you, you can take a look at the cheat sheet. It's going to be consistent and dependent. They depend on each other because it's the same line. Consistent and dependent. All right, let's go ahead and do number 6. All right, just by looking at it, I know that they're going to have the same slope because they have the same things on the left side of the equation. The y-intercept is obviously going to be different because it's a 6 over here and it's a 7 over here. But I'm going to go ahead and show you how I know that that's true because we're going to end up taking away 2x and dividing by 11 on both of them. So 11y equals negative 2x plus 6. Divide by 11. Y equals negative 211x plus 611. And the other one is going to have exactly the same slope because you're performing the same inverse operations. So 11w equals negative 2x plus 7 divided by 11. Y equals negative 211x plus 711. But I knew that because those two numbers were not the same, that these two numbers were not going to be the same, so that was not going to be the same line. But they do have the same slope. So these are parallel lines which have no solution, they never touch, and these are going to be inconsistent. All right, 7 and 8, and we are done. X minus 4y plus 1 equals 0, and 4y minus x equals 1. All right, so minus x minus 1. And I'm going to do it on the other side too, I just don't have room for it. So, and then I don't have to write plus 0. There's an invisible one right here. I am going to divide by that negative 4. So y equals 1/4 x plus 1/4 plus x. So 4y equals x plus 1 divided by 4. Can't forget my invisible 1. So y equals 1/4 x plus 1/4. Obviously, sorry about that, my babies. All right, obviously this is the same line because they have the same slope and the same y-intercept. So if this is the same line, they have an infinite amount of solutions. Consistent, and they depend on each other. So consistent and dependent. All right, let's go to number 8. That's the last one. All right, so for number 8, 3x minus y equals negative 2. And 4x minus 9y equals 5. So minus 3x minus y equals negative 3x minus 2. There's definitely an invisible one right here. Divide by negative 1. So y equals 3x plus 2. Minus 4x. So negative 9y equals negative 4x plus 5. Divide by negative 9. Y equals 4 nines x minus 5 nines. Now obviously these are not the same line, and they're definitely not parallel because they do not have the same slope. So these are going to have one solution. They're going to be consistent and independent. All right. And that is all for today, my babies. I hope you guys have a great night. I'll see you guys tomorrow.